All right, so this is a potential energy problem, and it says you have a 0.121 kilogram apple. It falls from a tree to the ground 4 meters below. You're ignoring air resistance here. So they want you to determine the gravitational potential energy, the kinetic energy, and the total mechanical energy when its height above the ground is the following. The first one we want to do is potential energy. Remember, it's just you. And U, we're going to put a little g down on the bottom so that you know it's for gravity. And that's just m times g times h. And we can plug all of our numbers in. The first number is 0.21. And this time, just for fun, let's use 9.8. And the height here is 4. So if you multiply all the numbers together, you should end up with 8.2 joules of potential energy. So remember, this is for the height of 4, and we'll do them just across, and then we'll do the next height. So we're going to do each one of the heights consecutively. So this is for the 4 meters. We know the potential energy. The kinetic energy, when you do this one, is really easy because it's 1/2 mv, and we have to square that, and we know that one's just equal to 0 because there's no speed at the very top. So your total energy would be equal to your potential energy plus your kinetic energy. We know that that should be equal to 8.2 joules. So that is for 4 meters. Let's do the same thing for 2 meters. So we'll put a 2 meters here. We better put a meter there, somebody get confused. For the first one, we know that the total energy is always going to be 8.2 joules. So we're going to start with it. The potential energy here should be equal to mgh. We know the mass is 0.21. Gravity is 9.8. We've got to keep that consistent when we go through. You can't switch back and forth between 9.8 and 10. You got to make a choice. So we chose the 9.8 this time, and we put in the 2, and you end up with 4.1 joules. So in order to find the kinetic energy, we can just say that the total energy is equal to the potential energy due to gravity plus the kinetic energy. We know that E is 8.2 joules. We know that U is 4.1, and so if we solve for K, we'll find out that K should be equal to 4.1 joules. So all you had to do there was just go through and substitute the 2. And then finally at 0 meters, we know at the very bottom all of our energy, our total energy, is 8.2 joules. We know because 0 is our height, the potential energy would be 0 joules. And we know that due to the conservation, our kinetic energy has to be 8.2 joules. And that is your first sample problem for potential energy.